Okay, this is lesson 7 in your textbook on page 599, and this will actually be the last lesson on your unit on characteristics of linear relations. And it's actually going to tie in a concept that you learned in the previous unit, which was on slope. So a few things that I just want to quickly go through before we start. So just remember that there are sort of two formulas for slope. And we denote slope using the lowercase letter m. So slope was equal to rise over run. Um, but more commonly, you'd use the formula if you have 2 points, y2 minus y1 over x2 minus x1. And any 2 points in a Cartesian plane, and you'd be able to calculate the slope, okay, between those 2 points. So this lesson, it's called Slope as a Rate of Change, and it's going to look at practical life examples, real life examples on how we're going to apply slope in different situations. So part 1 says the graph shows the distance traveled by a car as a linear function of time. So on the y-axis here, they have distance, and on the x-axis, they have time. So what it's basically showing is that as time goes on, the further the distance the car will travel, essentially is what this is saying. Now, if we have 2 points, we could calculate based on these 2 points the slope of this line segment by using our formula of slope is equal to y2 minus y1 over x2 minus x1. So in order to be able to do that, let's label our 2 points. So x1, y1, x2, and y2. And then simply from here, we're just going to plug in our formula. So y2 minus y1 would be 120 minus 40. And x2 minus x1, there's x2 minus x1, so 3 minus 1. 120 minus 40 is 80 divided by 3 minus 1 is 2, and 80 divided by 2 is 40. Now, up to this point, we got, okay, the slope is equal to 40, and you would convert that into a fraction 40 over 1, right? So what it's saying is that you would rise 40 and run 1, and you'd be back on your graph. You'd rise 40 and run 1. But now what we have to do is we have to figure out, what does this 40 over 1 mean in terms of something called rate of change? So what I always tell students is we know that the numerator, this top number here, that was our y-axis. So go to the y-axis on the graph and figure out, well, what was y talking about? And y was distance, which was kilometers. So I'm going to put 40 kilometers there. Divided by 1 what? What was the denominator? So denominator was or x values. And if I go to my x-axis, the denominator was representing time in hours. So I'm going to put hours there. So the slope of my graph is 40, but what that means is that this is a rise, right? So we know that this slope is rising, and it's a positive slope, and it's increasing at 40 kilometers every hour. So when the car drives 40 kilometers, each hour essentially. So if I said, well, how far would he drive in 2 hours? It'd be 80 kilometers, right? And in 3 hours, he would drive 120 kilometers. So complete the following statements by choosing a correct alternative and filling in the blank. The distance is increasing. So that would be an increasing distance. A decreasing distance, we'll do an example of on the next page, but that would be a decreasing distance, and that would be a negative slope, right? An increasing distance is always going to be a positive slope. So the distance is increasing at a rate of 40 kilometers per hour, and that's what we call or refer to as a rate of change. Part 2. The graph represents the temperature of an oven as a linear function of time. So when you turn on your oven, at 0 minutes, your oven doesn't start at 0 degrees, right? Your oven's not at freezing point, right? Your oven might be, it says 50 degrees or 50 degrees Fahrenheit here. So when you turn on your oven, the room temperature, it's saying, is basically 50 degrees Fahrenheit. And as time goes on, your oven is going to increase. And then this is showing that at 5 minutes, your oven will be at 350 degrees Fahrenheit. So if I asked you a question, well, how long did it take the oven to heat up to 350 degrees? It took 5 minutes, right? So that's how you would sort of read and interpret this graph. So there's my y-axis, this is my x-axis. So calculate the slope of the line, A. We know that slope is equal to y2 minus y1 over x2 minus x1. Slope is equal to, go to your 2 points and denote the first point as x1, y1, and the second point as x2, y2. From there, simply plug it into your formula. So y2 minus y1 would be 350 minus 50, and x2 minus x1 is 5 minus 0. Slope is equal to 350 minus 50 is 300 over 5. And 300 divided by 5 is 60. It's important though when it's a rate of change and you're talking about a real life situation, 60 what? What does that 60 mean? So I always say first put it over 1. And then we know that slope is y over x. So if I go to my y-axis was the temperature of the oven in degrees Fahrenheit. So 60 degrees Fahrenheit, it's going to heat up every 1 minute. So every minute, the oven's going to heat up 60 degrees. At 2 minutes, you should be at 120 degrees, right? And it's going to be an increasing slope. So what units are used to represent this rate of change? So the units are degrees Fahrenheit per minute. Complete the following statement. The temperature of this oven is increasing at a rate of 60 degrees Fahrenheit per minute. Flip over to part 3. So now we're going to look at a decreasing rate of change, right? And if you looked at this graph from when we did relations and functions, you would say, okay, that's a negative slope, right? You should just be able to look at that and say that that's going to be a negative slope. So hopefully when we do our calculation, we're going to get a negative number. Let's see what this graph represents. So it says the graph shown represents the amount of fuel in a gas tank as a function of the distance traveled. Okay, so as you drive, your car, let's say, is on full, and the farther and farther you drive, as you drive, your gas tank goes down and down, right? The amount of fuel that you have in your tank will decrease the more distance that you drive. So that makes sense. Let's calculate the slope. Y2 minus y1 over x2 minus x1. Let's find our 2 points and denote them as x1, y1. Your second point, call x2, y2. Students will sometimes ask in class, does it matter which point is x1, y1, x2, y2? And the answer is no. You will get the exact same answer. I tend to, whatever the first point I see on my graph, call that the x1, y1, and the other one the x2, y2. But if you plug it in according to the calculation, if I called this one x1, y1 and this one x2, y2, I would get the exact same slope. And you could test it out if you want to. So y2 minus y1 is 40 minus 50. x2 minus x1 is 120 minus 20. 40 minus 50 is negative 10. And 120 minus 20 is 100. Remember, we always reduce our fractions. So if you needed to, you could type in on your calculator negative 10 divided by 100. Enter, hit math one fraction. Negative 1/10. Okay, so that is what our slope is. But now let's figure this out as a rate of change, right? So rate of change means we're dealing with a real life situation. So in my numerator, that's where the y-axis is, and that was dealing with the number of liters in my fuel tank, right? So the number of liters. And then the distance, my x-axis was my distance traveled in kilometers. So how I would read this as a rate of change, -1 liter, what that means is my fuel is going down 1 liter every 10 kilometers driven, right? Your tank is decreasing 1 liter every 10 kilometers driven. So what units are used to represent this rate of change? Liters divided by kilometers. Complete the following statements. The amount of fuel in the tank is decreasing. The rate of change in the fuel tank is -1 over 10. So you always write your slope. So it's decreasing -1/10 liter per kilometer. Okay. Determine the equation of the line, and we're going to actually skip this one. You would use a method called slope point form, and we're actually not going to teach this method in distance learning because you won't use it in 20-1 or 30-1. Okay, let's do one more class example, and then I'm going to give you a couple questions to practice for homework. So question for class example number 1 says, Tyrone is paid a base salary per week, plus he gets commission for selling electrical appliances. Last week, his sales totaled $3,500. So he sold that much and he earned $620. This week he earned $680 for sales of $4,250. So it says on a grid, plot the ordered pairs to represent the information. Okay, and it wants its sales in the y-axis and his earnings on the x-axis. So last week, he sold that much and he earned that much. So it's always x comma y, and they want our x-axis to be his sales. So this number is going to go on our x-axis, right? He sold $3,500 of electrical appliances that week, and they want the y-axis to be the earnings. How much did he earn for selling that amount of money? So he earned for selling $3,500. He earned $620. Okay, so I need to plot this. So sales, 3,500. So let's just say this is $0 in sales, 1,000, 2,000, 3,000, 4,000, 5,000. So 3,500. So 0, 1, 2, 3. Let's just pretend that this coordinate represents 3,500 in sales and $620 made. That would be the first ordered pair. The second ordered pair is for this week. He earned $680. So remember, earnings goes in the y-axis. So he earned $680 and he had a sales of, he sold $4,250 in electrical appliances. So $4,250. So if that's 1,000, 2,000, 3,000, 4,000. So let's just say that that's approximately 4,250 and 680. Okay, so I've got my 2 points plotted. These would be the 2 coordinates here. And then what we need to figure out is what is the slope of this line. And I'll put in my second coordinate, which was $4,250 and 680. Okay, from here, let's label our 2 points. So x1, y1, x2, y2. A says on the grid plot the ordered pairs to represent this information, which we've done. B says calculate the slope of the line joining those ordered pairs. So the slope of the line segment is y2 minus y1 over x2 minus x1. Y2 minus y1 is 680 minus 620 all over x2 4250 minus x1 3500. $680 minus $620 would be $60. Over 4250 minus 3500 would be 750. We're dealing with money. So if I type in $650 divided by 750, I'm actually going to keep, because we're dealing with money, as a decimal. Sorry, that should be 60 divided by 750. Okay, 0.08. So let's see if we could figure out what that means. 0.08. That is money, right? So how much money is that? That would be 8 cents. And remember, it's always the y axis over the x axis. So y is how much he earns. So 8 cents he earns for every $1 sold. So explain what the slope of the graph represents. He earns 8 cents for every $1 sold. Okay, and that's all we're going to do for, we're not going to do D, E, or F, because for this course and for distance learning, you just essentially need to know how to calculate the slope in real life situations and what does that mean. So for your homework, there's a couple of things that I want you to do. The questions in your notebook here, I want you to do for A, B, and C. So it's pretty much what we did in class, and I could help set up this first one if you want. Sean is paid a base salary per month plus commission, so it's very similar to the one we just did. Her sales go on the x-axis and her earnings go on the y. So it's sales and earnings. So the first ordered pair, it says in January, her sales totaled 10,500 and she earned 2460, right? So you would take that and you would plot that somewhere. So 10,500 and 2460. And then the next ordered pair is for February. Her sales were less. So her sales were 9,350 and she earned, again, less money, 2322. So if I said, well, plot this, your x coordinate is less, as is your y coordinate. So this second point maybe would be here, 9350 and 2322. And then from there, you're going to get the slope of that line. Okay, so I want you to do 4ABC. And for number 5, I want you to do ABCD. And just to help set you up with this one, they want water level to go on your y-axis. So the water level in centimeters, because time we always put on our x-axis. And in this scenario, time is going to be in minutes. Okay, so just to quickly read what's happening is water is leaking out of the bottom of a barrel at a constant rate. So you've got maybe so much water in a barrel, and as time goes on, the water's leaking out. After 3 minutes, the water level is 58 centimeters. So think about that. Can you guys figure out what the ordered pair would be after 3 minutes? So where does minutes go according to x comma y? So minutes go on your x-axis, right? And your y-axis is water level. So my first ordered pair at 3 minutes, the water level is 58 centimeters. So at 3 minutes, 10, 20, 30, 40, 50, 60. Let's just say that's your first point. And then the second point, after 8 minutes, the water level is 23 centimeters. So after 8 minutes, the water level is 23 centimeters. So 3 minutes, 4, 5, 6, 7, 8 minutes, it's 23 centimeters. So label your two ordered pairs. Call your first one x1, y1, this guy x2, y2, and see if you could answer A, B, C, D. So you're only getting 2 questions from the workbook. And then what we're going to do is we're going to re-upload that practice exam that you wrote for your last unit. And we're going to assign the rate of change questions on there. Okay, so we'll upload that for you and let you know what questions we want you to do from there.